Okay, guys, so we're going to be covering multi-step equations, which is a review of problem set 26 that we did before the break. Listed here on my board are the 4 rules that you can find on page 110 of your problem set 26. Please make sure that you write these down somewhere where you can easily refer to them. Your homework is not going to be page 20, problem set 26. It's actually going to be a worksheet that looks like this. Okay, it's a worksheet that looks like this. Hopefully you can see that. I'm going to have that uploaded in GradeLink, and then you'll just need to either write the problems on a piece of paper, or you can write them on this, print it, and write it on this. It's up to you. But you're going to use these 4 steps to do that worksheet. I've written down example 3 from problem set 26, and you can follow along with me on how to do this. Okay, so we see that we have a 3x and a negative 1x and a negative 1x over here. On the left side of my equal sign, I have 2 variables. Now, I inserted the 1. It wasn't there previously. It looked like that. But I put a 1 so I could have a coefficient in order to combine the 3x and the negative 1x. Now, as previously taught to you guys, I just connect those 2 together, putting them in the same group or the same family, if you will. You can rewrite them as 3x minus 1x if you would like, but I'm not going to do that because I don't have space. I'm going to connect the coefficients over here as well. I'm going to go ahead and keep my equal sign. On the right side, the same terms are only the constants, so I'm going to put these together. The negative 1x does not have another variable, so I have nothing to connect it with. Back on the left side, I'm going to simplify each side by adding like terms first. Remember that you're not going to do the inverse operation on each side. Okay, you're going to do adding of like terms using addition rules. So 3x and negative 1x would be 3 minus 1 is 2x. I'm going to take the positive 2, the positive 4, and that's going to give me a positive 6. On the right side, I'm going to put the variable first because variables always come first in an equation and constants go last. And then I'm going to combine the negative 5 and the negative 4. Now recall that the rules for addition state that when the signs are the same, we have to add the terms. So since they're both negative, we're going to add 4 and 5, and we're going to get negative 9. The reason it's a negative is because we want to keep the sign from the bigger number. 5 is bigger than 4, and it has a negative in front, hence it is a negative answer. Now I'm ready to eliminate the variables on one side and eliminate the constants on the variable side. So let's begin with the variables. I want to choose either to move the x's to the left or to the right. The way you make that decision is usually depending on how you will get a positive variable answer. If I move the 2x using my inverse operation of a negative 2x, that means I'm going to have a negative value over here, and I don't want a negative variable. So rather than do it to the left, I'm going to take the x and move it to the, rather than move it to the right, I'm going to take the x and move it to the left. So by using my inverse operation right here, negative 1, positive 1, that cancels out. Whatever you do to one side, you always do to the other. So I'm going to put it under the variable, and I'm going to come up with 3x. Okay. At this point, I'm going to bring everything down. So I'm going to bring the positive 6 equals the negative 9. Okay. Now I'm ready to do step 3, which is since I moved the variables to the left, I need to move the constants to the right side so that I have one set of variables on the left, one set of constants on the right. Okay. So I'm going to do that by using my inverse operations again. And once again, remembering that I'm adding negative 9 and negative 6 because they have the same sign, I'm going to get negative 15 equals 3x. Now I have a simple one-step equation in which I want to solve for the variable. Now I've taught you guys to box it as a kind of like a symbol that you're isolating it. Recall that isolating the variable means you're going to solve for it or get it all by itself. So the inverse of a multiplication problem is division. So we want to divide by 1/3. By 3. Divide by 3. X equals negative 5. And that is your solution. Now, if this was a fraction, for example, if this was 1/3 x, you would not divide by 1/3 x. You want to flip the fraction and use the reciprocal on both sides rather than divide by 3 so that you don't have a complex fraction. Okay? One thing I would like to point out is be aware of undefined problems, meaning if you come up with a situation where the numerator has a value but the denominator is 0, remember the solution must be written as undefined. On the worksheet, you will see several problems in which the denominator is 0. And recall, you can solve it, but you have to make sure that it is undefined. If you come up with a solution where you have 0 over 0, we call that indeterminate. Okay, indeterminate. Because you cannot have a 0 in the denominator. Okay, indeterminate. If you have a solution that you come up with 0 in the numerator and anything else in the denominator, such as 0 over 4, this reduces to 0. So there are 3 different situations you need to be aware of. Undefined has the 0 in the denominator. 0 over 0 would be defined as indeterminate. And then a 0 in the numerator with a valid real number in the denominator, the solution is 0. So please be aware of those different situations. Now, looking at your worksheet, I see that you do have a distribution to do on some of the problems. So I am going to go ahead and make a part 2 video for you so that you can see how to do the distribution problems along with the multi-step equations. So please make sure you follow up with this lesson with video number 2.